Hello, in this video we're going to be talking about circle theorems that you need for GCSE. Here are the 8 that we're going to discuss. So let's start off with this one. This says simply that the angle at the centre is twice the angle at the circumference. So I can move this one around, it still stays at 55 degrees, and this one in the centre is exactly twice. Now you might think, well hang on, 2 lots of 55 is 110. Well, this is because I've set the rounding to be 0 decimal places, but you can see if I adjust it so we've got more decimal places, then yeah, the angle at the centre is exactly twice the angle at the circumference. So I'll stick that down to 0 decimal places to make it easier. As you can see, as we move these places down here, the angle at the top reduces, but the angle at the centre is still exactly twice the angle at the circumference. So most students can spot this quite easily, but how about if I disguise it? How about if I move these 2 points up here? Now we'll see that the angle at the centre is still twice the angle at the circumference. Let's just move it until the rounding makes it clear. But it doesn't look like the original diagram. So how about also if I move this point all the way around to here and have something like the original diagram, but now it's sort of on its side? Would you still recognize this as the same circle theorem? And a couple more ways that I can disguise what's going on. Look at this, the angle at the center is 88 and the angle at the circumference is 44. But again, it doesn't look like the original diagram. And a final way I can disguise it is like this. Now it looks significantly different to what we started with. But again, the angle at the center is still twice the angle at the circumference. Okay, let's move on to circle theorem number 2. This one says the angle in a semicircle is 90 degrees, and you should try to memorize these word for word, because the questions in GCSE often ask how big is this angle and why? And this follows straight away from the first one, because look, this angle here is 180 degrees because it's a straight line. And so therefore, of course, this one's 90 degrees. So I can move this point around. The angle in a semicircle is always 90 degrees. Circle theorem number 3 says that angles in the same segment are equal. So look at this. I can move this one anywhere around here. As long as I stay in the same segment, it's still going to be 31 degrees. As soon as I move down here, it's not 31 degrees. But that's because I'm not in the same segment anymore. I'm in the alternate segment. I can move one of these 2 points and then both of these other angles change, but they're still the same. Angles in the same segment are equal. So why would that be? Well, quite simply because if the center was marked on, then each of these angles, these 48-degree angles, is half whatever the angle at the center would be. So we can see this would have to be 96, so these would each have to be 48. Circle theorem number 4, opposite angles in a, well, what sort of four-sided shape is this? It's a quadrilateral because it has 4 sides, but it's a special quadrilateral because the 4 corners just happen to lie on a circle. So this is called a cyclic quadrilateral, like a cycle, like the wheels on a bicycle. So that's why a 4-sided shape whose 4 corners happen to lie on a circle is called a cyclic quadrilateral. So let's just move it around and check. Look at this, 105 plus 75 does indeed add up to 180. Let's move this point. What have we got now? Now we've got 96 and 84. They again add up to 180. So opposite angles in a cyclic quadrilateral, we've always got them adding up to 180. So there's a whole load of things that add up to 180. We've got angles in a straight line. We have angles in a triangle. Now we have opposite angles in a cyclic quadrilateral. That's the first 4 of our circle theorems. Let's move on to tangent meets radius at 90 degrees. This line here is a radius joining the center to a point on the circumference, and this long straight line here is a tangent. It's a straight line which just touches a circle. So tangent meets radius at 90 degrees. Surprisingly difficult to prove, but most people can look at that and say, yeah, I think that's obvious that they meet at 90 degrees. We'll come on to this bad boy in a minute. But let's first of all have a look at this one. It's one of the lesser known ones. It says that radius bisects a chord at 90 degrees. So here again we have a radius. Let's just move it around, see that it's still always the same. And if it's cutting this chord here, into two equal bits, if it's bisecting this chord, then the rule says it has to do so at 90 degrees. So I can move these around. This angle here is always going to be 90 degrees. Okay, let's move on to this one. At GCSE, you tend not to have to explain in words what's going on, but the circle theorem merely says that these two red lines joining a point outside the circle, and if you draw these tangents from this point to form these two red lines, then they're always the same length. And I can sort of move them around a bit. As you can see there, wherever I put this external point, it's the same. If you wanted to put this into words, you would say the tangents from an exterior point to a circle are equal in length. Bit of a mouthful, yeah. And the other circle theorem that's going on here is that these two angles are the same. So how do we explain this in words? Okay, the line joining the center of the circle to the exterior point bisects the angle between the tangents. Whoa, what a mouthful. Let's just try this again. So the red lines are the same length. How do we say this? We say the tangents from an exterior point to a circle are equal in length. And then the one that says that these two angles are the same, this one says the line connecting the center of the circle to the exterior point bisects the angle between the tangents. That just leaves one more, which is this one, the infamous alternate segment theorem. This one is so difficult to put into words that in GCSE exams you are allowed to merely say the alternate segment theorem. So let's just fiddle about and move these points and see what happens. As you can see, these two green angles are the same. They're now both 70 degrees. If I move it around, they're now both 64 degrees. They seem to be staying the same. Meanwhile, if we have a look at the red angles, they're both 57. I can move this one. Oh, they're both changing, but they're both 36. I can move this point, swing it around a bit. Now they've changed, but they're both still the same. So what does the alternate segment theorem say? Well, I like it. It's easy to spot because it's the only one of the circle theorems that needs both a chord. So a chord, this is a straight line joining 2 points on the circumference, but the straight line does not go through the center. If it goes through the center, it's a diameter. Let's see a diameter. There we have a diameter, but here this line is a chord. So it has a chord and it also has a tangent, which is this straight line that just touches the circle. Let's just move it around a bit. There you have a tangent. So here we go. This circle theorem is the only one that has both a tangent and a chord. And it says the following: the angle between the tangent and the chord, so say the red one, is equal to the angle in the alternate segment, so round the other side. The same circle theorem says that these two green angles are the same. So this 64 degree one here is the angle between a tangent and this chord, and it's equal to the angle in the alternate segment. So there we have it, the 8 circle theorems that you need for GCSE.